Hello everyone. Welcome to this video where we're continuing with the series of videos on the design of supply chains, and we are working on capacitated facility location problems. We looked at the regular capacitated facility location problem in the last week. This week we are doing capacitated facility location with single sourcing. To that end, what I'm going to do is I'm going to copy some of this data over, because you have to change the setup a little bit for the single sourcing problem. So let me make I'll copy it over to a new book actually. Let's do this here. I'm going to save this as capacitated facility location with single sourcing. Let me get rid of all of the numbers here. Clear my contents. All right. So the setup is for the most part the same. There are going to be differences, obviously, and we'll talk about the differences in a second. But setup for the most part is the same. The way we write the total cost and everything are going to be different. But let's see how this thing will turn out, right? Okay. Now, first things first. All of these variables here. Every single variable here is going to be a 0-1 variable. So because it's going to be a 0-1 variable, Excel might take a little while longer to come up with a solution. So don't worry about that. Sometimes Excel will churn for maybe 5 or 6 seconds, maybe even up to 10 seconds to come up with a solution. Don't worry about that. It's working. Not a problem. All right. Okay. So let's see how we set up our variable cost and fixed cost. So now we'll have to separate our variable cost and fixed cost values. We won't be able to write a single sum product formula. We're going to have to separate them into two separate formulas. So we'll say sum product of first the fixed cost values. The fixed cost values are simple. We'll just look to see if a particular factory is open or not. And if the factory is open, and I think I messed up. Okay, still have the sum product, so let me. Why is my mouse so uncooperative today? Okay, all right. So sum product of the open close variables, right? The open close variables, comma the fixed cost values, right here. These are my fixed cost values. So this part is pretty straightforward. So we had fixed cost values and all of that. So we wrote our first part of the objective function. That's the first part of our objective function. Now let's write the second part of our objective function. The second part of our objective function. Now you'll notice that, so let's say that this number here is 1. It won't be 1, right? Because low capacity plant will not be able to satisfy all of North American demand. But let's say that this number was 1. So if this number is 1, you're essentially saying that you're going to multiply this number, right? So if this number is either 1 or 0, you're going to multiply that number with the corresponding cost, right? And to that, you're also going to multiply the corresponding demand. Right, so the demand is 12, because if this plant is assigned to this demand region, all demand from that for that particular region has to be satisfied by that plant, right? So it'll be the demand times, right? So it'll be demand times the variable cost values times the Xij values, right? So now this is going to be tricky. So let's see if this will work, and I will show you one way to do it first, and I'll show you why that won't work. So you're going to multiply the Xij value. So this time, remember, it's only the Xij values, just the decision variables corresponding to the variable cost, comma the corresponding variable cost values, right? So variable cost values, comma. Now this time you have to write demand number, so you have to multiply the corresponding values with demand. So you cannot just use demand this way and hope for it to work, right? So if I write demand this way, right? So I can do some product with 3 different shapes. That's not a problem at all, right? Yeah, I can do some product with 3 different shapes. That's not a problem. It's just that all 3 shapes have to look exactly the same. That's how the sum product function works. If I do that, it is going to throw up an error. So because when I have my variable cost values, when I have my Xij decision variables and my variable cost values, you essentially have 10 rows and 5 columns. My demand also needs to have 10 rows and 5 columns. Otherwise, this formula will not work. You'll just have to write the formula a different way. So there are two. So like I said, there are two ways to go about it. You can just write the formula a different way, or where you write it row by row. You write a separate formula for each row. That's one way to go about it. Or the other way to do it is, well, let's create a demand demand shape that looks exactly like the other two shapes. I'm just gonna copy this over. I'm gonna say demand, right? Demand was that, and I'm just gonna copy paste the same thing. Did I get enough? Nope, I have too many. Right. Okay. Now when I write the formula, right, instead of using just a single row of demand, I'm going to use all 10 rows of demand. Now that's not a problem, right? So it's going to multiply the corresponding X value with the corresponding variable cost value and multiply it with the corresponding demand. I just repeated the exact same demand numbers. I took the demand numbers and I repeated it, right? 14, 16, 7. Yeah, that's it. And that's my total cost value. And so a little bit of change just makes your life easier. So remember, so you're multiplying 3 different numbers together. And how do I know I'm multiplying 3 different numbers together? So if you actually look here and the formula sheet, there are 3 different numbers, right? So you're multiplying demand with the cost with the corresponding Xij. So this was the Xij values, then the variable cost values and the corresponding demand. And that's what we did, right? So demand, Xijs and the variable cost values, right? And there you go. That was your total cost. Now again, you'll be minimizing total cost. No problems there. Now let's move on to our 2 constraints. So we have the capacity constraints and demand constraints. Now, demand constraints are easy. So in this case, demand constraint all transform into ones, right? So you say that every demand location is assigned to only a single supply location. So let's look at this constraint. So if I look at this constraint right here, this is saying if I look, I'm going to add up all of these Xij values. So all of these Xij values, again, remember, they're all 0 1s. So they're all binary. So if I add up all of these numbers, they all have to add up to 1. That's my constraint. Why does that constraint make sense? You're saying that the North American demand region has to be assigned to one and only one source. That's the single sourcing, right? The one source here can be any one of these factories, and we'll figure that out once we solve the problem. Right? The same goes here. So by changing all the demand values to 1, we have written this as the assignment constraint. Now let's look at the capacity constraint. Now even the capacity constraint is going to be slightly the right hand side is the same. So if you look at the capacity values, you'll notice that the capacity values are, for the capacity constraint, the capacity values are Ki times Y. So this is essentially, the capacity values are essentially saying your capacity is either 0 or 10 or 20 depending upon low capacity or high capacity, right? So your capacity is so you're multiplying the capacity number with the open close number. So if you don't open a North American factory, low capacity North American factory, then your capacity for the low capacity North American factory is 0, because this variable will be 0. 0 times 10 will be 0, right? So no capacity available. But if you do open the low capacity North American factory, then this will be 1. You'll multiply the 1 with 10, and that becomes your capacity, right? So that part is straightforward, but it's the amount supplied that is going to change, because right now the amount supplied is just the sum of the Xij variables, and that will not work, right? So in this case, you're adding up a bunch of numbers that are either zeros or ones. What we need to add up are the corresponding demand values. So essentially, you're saying that if the North American low capacity plant is assigned, let's say, to the African demand region, and that's possible because the low capacity plant has a capacity of 10, the African demand region has a demand of 7, so the low capacity North American plant can be assigned to the African region. And if that is the case, you want this number will be 1. But when I write my capacity constraint, I don't want the left-hand side to be 1. I want the left-hand side to be the corresponding demand value because the whole demand is getting supplied. So once you assign this factory to this region, the whole demand of 7 is assigned to that plant, and so the capacity, so that much capacity is used up at the plant, right? So instead of writing it as just the sum of the Xij values, it is Xij times the corresponding demand value. So we will write it as sum product, right? Sum product of the corresponding Xij values. So these are the 0, 1 numbers, comma, the demand values, right? All right. So if this number is 1, then all 12 million units are coming out of this plant. If this number is 14, then all 12 million units are or 14 million units. Sorry, if this number is 1, then all 14 million units are coming out of this plant. And that's essentially what you're saying. Okay. All right. Now, it is possible that a single high capacity plant can supply both South America and Africa, right? Because South American demand is 8 million, African demand is 7 million. If you add them up, they add up to 15 million. So a single high capacity plant can supply both regions, right? So single sourcing doesn't mean that one source has to supply only to a single demand region, right? So you're saying that let's say that you have a factory in a high capacity factory in Africa. This high capacity factory in Africa can supply 7 million units to Africa, and the same high capacity factory in Africa can supply 8 million units to South America, and that satisfies our conditions because everything going to Africa is coming out of a single plant, and everything going to South America is also coming out of a single plant, right? So given those factors, so we are allowing for that too. So that's why we write the sum product function the way we write the sum product function, right? And that's my first constraint. So instead of a sum function directly adding up the Xij values, you're going to multiply the Xij values with the corresponding demand values and then add them up. So that's the left hand side of my constraint there, and I'm just going to copy it all the way down, and that should work, right? So if you look at the African constraint, the last one, African high capacity plant, everything here, oops. So everything here, right? And the demand values. The demand values are all the same, right? And there you go. Now with this setup, the reason I changed everything within the existing setup is that so now I don't have to change stuff in Solver except for one thing, and we'll do that in a second, right? So let's look at Solver. So I'm going to go to data, I'm going to open up Solver, right? Now in Solver, we have the demand constraint. In this case is the assignment constraint, and the supplier, the capacity constraint, which we have that set up. Now the binary constraint has to be changed. So you can either delete it and add it again, or I'm just going to say click on change. And here it's saying that only the open close variables are binary. Now I'm going to choose that. I'm going to say all my variables are binary, right? Everything going from B17 all the way up to G26, they're all binary. I'm going to click OK, and that's it. So once I've made this change, I'm going to click on solve. Oh, Solver did find a solution. All right. And there you go. So now you'll notice that we have actually opened 4 factories, and then this was likely going to happen. And the way we opened it, so we've opened a low capacity factory in Africa, and this low capacity factory in Africa is the one that's supplying all the demand within Africa, right? Then you are opening a high capacity factory in South America, which is satisfying all demand in North America and South America put together. So 12 million plus 8 million, 20 million, you're using up the total capacity in South America. Next, you're opening a high capacity plant in Asia that is satisfying all demand in Asia, and you're opening a high capacity plant in Africa, which is satisfying all demand within Europe, right? So you're building two different factories in Africa. You're building a low capacity factory in Africa, which will satisfy demand within Africa. And you're building a high capacity factory in Africa, which is going to satisfy all demand in Europe. And that is what you're doing. Now, it is possible that you might say that, hey, we cannot put two separate plants in the same country. And if that's the case, we'll have to write more constraints for that. And we'll get the same, not country, I'm sorry, the same region. So these are continents, obviously. So we cannot put a low capacity and a high capacity plant both in the same region. If that's an extra constraint, well, that will increase the total cost and everything, but we'll get to that in a second. Now, you'll notice that the total cost here is 26,501. What was the total cost in the other case? Is 22,498. And always remember, whenever you add extra constraints, your costs are always going to go up, right? So as you add more constraints, your potential set of solutions goes down, and so you're looking at more and more costly solutions, right? And that's the idea. Okay, and that was our right there. Okay, so that was the plant. So a few more things to see here. The South American plant is used up completely, right? 20 million units. But none of the other plants are used up to capacity. The African plant has a 3 million unit capacity. The low capacity African plant has a 3 million unit capacity. The Asian high capacity plant has a 4 million unit capacity excess. And the African high capacity plant has a 6 million unit capacity in excess, right? And that is the idea of single sourcing, right? I know I've already passed 15 minutes, but let me just take a couple of minutes to, so what if we add this extra constraint that only every region can have only one plant, that it cannot have both a high capacity and a low capacity plant? Well, if that's the case, we'll have to add some extra constraints, right? So let me add that constraint here. I'm going to, so actually let me make a copy. I don't want to mess with the original, so I'm going to call this single sourcing. I'm going to call this single sourcing, single factory, right? I'm going to call it single sourcing, single factory, where each region can have only a single factory. Now, how do I write that constraint? Now, that's pretty straightforward. So you're saying, so we're going to write a single factory constraint, right? The single factory constraint, you're going to have the 5 regions. So we already have that here. Just gonna copy that. Right. So right. Now I'm not going to have left hand side the two for this. I'm just going to do a single thing. So here I'm going to say this is North American low capacity plant plus North American high capacity, right? So these are the variables. So these variables here will be either zeros or ones. So this is either 0 or 1 if you open a low capacity North American plant. This is 1 if you open a high capacity North American plant, right? So I'm just going to copy this formula down, right? And my constraint is going to be that none of these numbers can be greater than 1. So I'm going to say all of these numbers are less than or equal to 1. By adding that constraint, I'm saying that you can have at most a single factory in a single region, right? So what happens when I add that extra constraint, right? So how does that change? I'm going to go to solver. I'm going to add an extra constraint. Now I'm going to say that all of these numbers here have to be less than or equal to 1, right? So they all have to be less than or equal to 1. So I'm going to click on OK. It got added. Now let me click on solve and let's see what happens. Okay. Now, so instead of opening we are opening a high capacity plant in South America that will satisfy North America and South America. We are opening a low capacity plant in North America, which is going to satisfy the demand in Africa. And we are going to open a high capacity plant in Africa that's going to satisfy European demand, high capacity factory in Asia that's going to satisfy Asian demand. So this way you only have one factory in each region. So I added the binary variables for high capacity and low capacity together, and I put a constraint saying less than or equal to 1, saying that both of the binary variables cannot be 1. That was the only restriction. Both binary variables being one means that you are opening both a high capacity and a low capacity plant in the same region. And if I say that that is not allowed, single factory in single region, right? If that's the case, then you add the extra constraint. And that's the idea. Once you set up the base problem, as and when you come up with more and more constraints, more and more restrictions on what you can do based upon union regulations, governmental regulations, or disasters or anything like that, if things change over time, then you can add stuff to the same problem and resolve the problem to get a better configuration for your supply chain, right? And that's the idea. So it's already over 20 minutes now, so I'm going to stop it here. And this was supply chain capacitated facility location with single sourcing. What we'll look at in next week is we'll look at more complex problems where how do you manage merger of two different supply chains. So two different companies with supply chain have their own supply chains. Now they have merged together. How do you merge the supply chain of those two companies? And that's what we'll talk about next week. Till then, take care, and I'll see you all in the next video. And don't forget to email me if you have any questions. All right, take care.